Okay, so we're on the last page of the notes. From Wednesday, yes. We didn't finish. Mm-hmm. Okay, so what I first need to do here is I need to go ahead and graph this. No, because it's slanty. I need to prove it though. So remember on Wednesday when we were doing this, so the first thing we had to do was prove it was a parallelogram first. So what I need to go do is I need to go find my slopes. So my slope of AB is so negative 1, negative 2, because it's going down and right, which is just 1/2. Okay, then I want to do the same thing for BC. So it's down 4 over 2. So negative 2. Okay, then I want to do CD. So as a slope, that'd be 1/2. Because the slope is always rise over run. Rise is up and down, run is left and right. D. No, there's more after we finish this one. But we're on the last page because we're almost done with this one. Okay, and then I have 80. Okay, so it's going down 4, right 2, so negative 2. Mm-hmm. Okay, so then we're doing a proof, so I want to do my statements and reasons. Mm-hmm. Okay, so the first thing I want to say is I want to talk about it being a parallelogram and my two parallel sides. So I'm going to say the slope of AB equals the slope of slope of CD, which is 1/2, and the slope of BC equals the slope of AD, which is -2. That is the slope formula. Slope. Okay. Then I can say that my two sets of lines are parallel, so I can say AB is parallel to CD. I wanted this all in one line. And BC is parallel to AD.
Why?
Definition of parallel, because they have the same slope. Okay, then I can say it's a parallelogram because now I have two sets of parallel sides. Okay, now I need to prove that it is a rectangle. What makes a rectangle more precise than a parallelogram? What do rectangles have that not all parallelograms have? 4 right angles. They have 4 right angles. So I need to talk about things that are right angles. So whenever I have opposite reciprocal slopes, so the signs are different and the fractions are flipped, I can say they're perpendicular. So I have AB is perpendicular to BC. BC is perpendicular to CD. CD is perpendicular to AD. And AD will be perpendicular to AB. So this is from the definition of being perpendicular. You have to have opposite reciprocal slopes. Perpendicular. Okay, so since I have 4 perpendicular lines, what happens at perpendicular lines? What kind of thing happens? What do perpendicular lines make? They make these little squares. What are those little squares called? Right angles. So I have angle A, angle B, angle C, and angle D are all right angles. This also comes from the definition of perpendicular. Okay. So now that I know I have 4 right angles and 2 sets of parallel lines, what can I say about this shape? Yep. And this comes from definition of a rectangle. Can I move on to the next one? Yeah. Okay. This one wants me to plot my points and then prove it's a square. But we have to write our proof now. So just like before, I want to prove it's a parallelogram first. Not really. Like as a kid, I did, but I don't really like milk at all anymore. I don't know. It's just like the texture of it's kind of weird, you know? Oh, yeah? Okay, so I want to prove it's a parallelogram first, then a rectangle, and then finally a square. So I have to work down that flow chart we did last week of the different shapes. Okay, so first thing to prove it's a parallelogram is I have to say that it has parallel slopes. Parallel sides. So I'm going to find my slopes. So I'm going to find the slope for AB. So what's my slope for AB? No. Okay. Then I want to do my slope for BC. -2/1 because it's going down, which is just -2. I have the slope of CD. 1/2. And then my slope of 80. So that one's not 1/2. -2/1, which is just -2. Okay, then I want to go ahead and do my statements and reasons. Yeah, we're going to write the slope formula part again. So I'm going to have slope of AB is equal to the slope of CD, which is 1/2. And then I have the slope of BC equals the slope of 80, which is -2. And that's by slope formula. Yeah, so I want to say the parallel line. So I'm going to have AB is parallel to CD, and BC is parallel to 80. And this is definition of parallel. ABCD is a parallelogram. Definition of a parallelogram. It's a parallelogram because it has two sets of parallel sides. Okay, so I've proven it's a parallelogram. Then my next step was to prove it's a rectangle. So what do I need to do to say it's a rectangle? I need to say I have perpendicular sides, right? So I have AB is perpendicular to BC. BC is perpendicular to CD. CD is perpendicular to AD. And AD is perpendicular to AB. Okay, now that I've said they're perpendicular, I can say that all those angles are right angles. So angle A, angle B, angle C, angle D are right angles. Definition of perpendicular again. Right on the back. Well, the black. I messed up on this one, so the backs of everything are. Okay. Then, now that I have its perpendicular, what can I say? What kind of shape is this? No, I can't say that quite yet. I've only proven it's a rectangle. I know. What do I need to prove to say it's a square? Squares have 4 right angles and 4, no, congruent sides. So I need to say I have my 4 congruent sides. So, if we notice, all of our slope triangles can't really see them so well anymore. But the red ones, when I did them, they were all the same triangle. So I just need to find the length of one of them. No, the length. So it was up 2 over 1. So then I'd use the Pythagorean theorem to find out the blue length, which is C. What's 1 squared? 2 squared? C squared is C squared. No, it just says C squared. And then what's 1 plus 4? Okay. Then I want to get C all alone. Square root it. And then on the calculator, what's the square root of of 5? .2. So now I can say, if all the side lengths are the same. So I'm going to have AB equals BC equals CD equals AD equals 2.2. This was by the distance formula. I know. The more precise the shape is, the more steps there are. No. But it's a shorter proof. It's not one of the longer ones. I think you just have to prove it's a parallelogram. So, like, these steps. Yeah.
How is 1 times 2 is 1?
Okay. So now that I know that those are the same length, I can say they're congruent. So I can say AB is congruent to BC, is congruent to CD, is congruent to AD. Definition of congruent. Okay, and then I only have one piece left. What is the piece left? Yeah, so ABCD is a square.